Okay, so our next unit, we're going to be starting Chapter 3. So your Chapter 3 info sheet was in your folder, and then you saw it on your table of contents where that is going to go in your notebook. This unit is going to be looking at different types of data than we looked at before. Before we were looking at what we call univariate data, just one variable being collected and analyzed. Now we're going to be talking about bivariate data, just meaning there are two variables we're measuring, and we want to see how they interact with each other. Okay, that's what we're looking at. So a scatter plot is one of the types of graphs that we can use to compare how these two variables affect each other. Okay, so that's kind of where we're headed with this. So scatter plots you've probably done before. Whenever you were way back in middle school, probably. Graphing points, looking at the pattern, seeing what do we see from the pattern. So the first rule of statistics is always make a picture. So we're going to be looking at making a picture of this data. So the picture, of course, is scatter plot. So in making a scatter plot, as you've learned already, the way we label things is important. Okay, we need to make sure everything is labeled and in the correct spot, and make sure we understand these variable names and the types of variables that we're looking at. So in statistics, when we're talking about the explanatory variable, that's going to be the independent variable. And typically we think of that as the x variable. If you think of it in terms of x and y, it's the x. The response variable is the dependent variable. Or the y. So the response variable is always the one we are predicting. So if you think about which one can I use to predict the other one, the one that is being predicted is the response variable. So if you're having trouble looking at the problem and deciding which one is which, just think of which one could I use to predict the other one, and the one that's predicted is response. So when you are graphing, you want to always remember the Tulsa principle. You can tell me what it stands for. Well, way to read it off the board. Good job. So, you should always check every graph you make and make sure that you have included all of those things. If you use that as a checklist to make sure that you've included it, you're good. You will have done everything that you needed to do. So, let's look at plotting some points. So, we have down here at the bottom some data. This is some SUVs, and it tells the weight of the SUV and the fuel economy. So, we need to decide which is explanatory and which is response. Would we use the weight to predict the fuel economy, or would we use fuel economy to predict the weight? What would make more sense? Yeah. It's going to be weight predicts the fuel economy. So this is my response variable, fuel economy. This is my explanatory variable. So the weight is the explanatory and the response is fuel economy. Changing the weight will affect the fuel economy. We think the change in weight is probably why the fuel economy changed. It's probably an explanation of that relationship in that direction. So when we go to make our graph, the explanatory variable is going to be along the x-axis. So weight down here, along with the units, pounds. And then the response variable will be along the y-axis, so fuel economy here. Miles per gallon. And then our title, I would say, what kind of vehicles are we talking about? We're talking about sport utility vehicles, so that's what I'm going to put as my title. So we need to figure out a scale. So when we look at the weight of the vehicles, the smallest one is 3,000. The biggest one is 6,694. Okay? So I'm going to start over here at 3,000. Let's see, this is 4,000, 5,000. I'm just labeling every other line, counting my thousands. And then for fuel economy, is 12 the smallest, 12 is the smallest, and 26, I think, is the highest. So we need to label that so that 12 to 26 fits along there. So if we label here 12, 14. Now we've done our title, we have our units, we have our labels, and we have our scales. So now we're ready to just graph the points. So you're just going to graph them as ordered pairs. This X with this Y. So let's go through and graph those points. Okay, so just out of curiosity, we're going to go over exactly what you need to do with this, but how would you describe what you see? Do what? It's scattered, okay. Anybody else have an observation? Negative slope, good. Any other observations? I'm just trying to get an idea of what you already know about doing these things. Okay, so when you are describing this, there are specific things that we usually include, and those are listed on the inside. So, first thing we talk about is the strength. Whenever we describe the strength, we're going to have three different words that we will use. It's either going to be strong, moderate, or weak. So if it's strong, it just means whenever I look at the graph, it's pretty easy to tell exactly where that line would go. If we drew a line of best fit in there, we're going to know pretty well where that goes. Okay? The points fit close to that line. If it's moderate, they're going to be still, you can tell if it's positive or negative, but it's a little bit more spread out. So maybe we can still see it's kind of going in a negative trend, but there's a little bit of movement around. It's not real tight, but it still appears to be a negative trend. It's like a little bit fuzzier. It's like when your resolution is not good and it's like, it's all pixely. That's moderate. Weak, I can't tell if it's positive, negative, what's going on. It's just randomly scattered everywhere. That's weak. So those are our three different ones. You want to see what does it look like. Okay. So in looking at those three types, what would you say this one is? Yeah, it's probably somewhere around the strong moderate. I would probably say it's probably still strong, but there could be stronger. Okay, so this one, tomorrow we will get to a calculation that you'll use to determine which one. I will actually be gone tomorrow. We have to go to Oklahoma City for my husband's recheck from his kidney transplant. So we got to go do that tomorrow. So I will have the notes recorded, and so make sure you bring some headphones or something, because it's going to get really noisy if everybody's listening to the Chromebooks all at the same time. So bring something, you'll watch the notes video, record your notes just as though we were doing this together, and then you'll have a problem set and some work to do after the notes. So make sure you bring something to listen. Okay, strength. Like I say, we'll talk more about that tomorrow, but for now, you should be able to identify as one of those three. Okay. Association. This is where we're looking at, it's either positive, negative, or none. So this is where you're thinking, from Algebra 1, you're thinking slope. Okay? So if it's positive, we're seeing a positive trend. If it's negative, it's kind of got a negative slope to the line. None would be this idea of this randomly scattered, we don't know which way it's going. You guys sound like you're enjoying drawing dots. Okay. So for association, we say positive or negative. On our graph we drew on the first page, what would you say it is? Positive or negative?
Negative.
Negative. Good. For form, this one we only have two options. It's either linear or nonlinear. So linear would be, looks like a line. Nonlinear, it may be something like this. It's all like curvy looking. It may be maybe something like that, where it just looks like kind of a parabolic curve. Something where it's not a line. Okay, so any kind of non-linear look. So when we're looking at a scatter plot, we're going to say it's either linear or non-linear. That's as specific as we have to be. You don't have to say what type of non-linear. Then unusual features, it could be, I'm going to use these same dots because they're bleeding through anyway. Could be we have this trend and then we have this guy sitting over here by himself. So it could be we have this outlier sitting out there where it's outside of the rest of the data. It's a trend. It's something where everything was going fine and then we have this thing out here to the side. When you do a scatter plot and you get something like this, double check your data and make sure you just didn't look at it wrong, you didn't enter it in the calculator wrong, you didn't, misrepresent what was actually there for some reason. But if you entered it accurately and you graphed it accurately, and there's a point that's outside the trend, that would be an outlier. Another thing that can happen with unusual features, sometimes you'll have like this same trend all the way through, but you got a group up here and a group down here and this big gap in between. So this is what we call either clusters or subgroups. So you can either call this, there's a cluster here and a cluster here, or there are two subgroups of data. But it's when we see a distinction between the groups of data. So, when we look back at our original graph that we did, here we would say, we're going to say there's a strong negative, linear, relationship between the vehicle weight and fuel economy with sport utility vehicles, or just SUVs. So that is the type of sentence you will use to describe a scatter plot. You're going to say strong, moderate, weak, positive, negative, or none, linear, nonlinear, and then put your variables into the sentence. You'll write it in that form every time. Questions up to here? You okay with it? Okay, this next part is how do we do this on the calculator? So what you're going to do is first you're going to clear out your L1 and L2, and then you'll enter the weight in L1, fuel economy in L2. So I'll give you guys a minute to enter that data. Okay, so once you have your data entered, we're going to graph this by going into our stat plot. So second y equals to get to there. And then you want to make sure the first one is turned on and the other one should be turned off. We want to select this first type of graph. This first one is the scatter plot. So you want to select that first one, L1 and L2 for X plus Y lists. And then I wouldn't select either one of those because they're hard to see. So one of the first two for the mark. And then once you have all that set, just zoom 9. And that'll set your window to be able to see the graph. So that should look similar to what we have on the front of our notes. So if we're drawing this, if you're using your calculator and then drawing that on your paper, you will just sketch what you see on the screen. So do that. Something similar to that pattern. It doesn't have to be super, super precise. It just needs to have the same basic shape relative to the other point. So even when you're just doing a graph on the calculator and copying it to your paper, you need to still follow that Tulsa principle. So we still need our title. We still have those. And then to get your scale, what you can do is just hit the window key underneath here. And then the X-min, X-max, you can just label those on here. So the X-min is 2630.6 and the max was 7063.4. And if you've labeled those, that shows the window size, so that's good enough. And then the same thing on the Y's. So I just label my X-min, X-max, Y-min, Y-max at the top and bottom or left and right of each one. And that's good enough for scale. Questions up to there? Are we okay with that? So far, all right? Okay, so your info sheet went on page 87. You're not going to put this back up here in case you still need it. So info sheet was page 87. The scatter plot, that's going to be on page 88. And then your problem set that was in your folder for today, that goes on page 89. And then I went ahead and put up those 90 and 91 are what you're doing tomorrow, but I won't be here to put my table of contents up, so you might want to write that down. So that leaves you guys about 10 minutes. You should be able to finish that problem set before you leave, that way you don't have homework. The notes, page 88.